Hi, this is lesson 11.3, perimeter and area of similar figures. So the first part here, areas of similar polygons. If two figures are similar, I'm having a hard time talking, huh? Then we know a couple of things about the ratio of sides and the ratio of their areas. We know that the ratio of sides, really I should add here, and perimeters, is equal to the ratio of corresponding side lengths. So if you have a shape and you know two corresponding sides of each of your shapes, one is A and the other is B. Let's just draw a picture here. Let's say this is figure 1, and this will be figure 2. You can say 1 is similar to 2. Triangle 1 is similar to triangle 2. And this is A and this is B. We could say our ratio for sides or perimeter would be A to B. The ratios of area is equal to the ratio of corresponding side lengths, but we're going to add one other word here, squared. So instead of A to B, I would have A squared to B squared. So let's look at example 1 here. It says in the diagram, triangle ABC is similar to triangle DEF. Find the indicated ratio. So we want the ratio of the perimeters or side length. Perimeter and side length is the same thing, from small to big. So side BC is right here, and EF, we know, is its corresponding side. So we can write 8 to 12, or if we reduce that, it's going to reduce to 2 to 3, and that's from dividing both pieces by 4. So 2 to 3 would be my ratio of the perimeters, or also the ratio of side lengths, either one. B, the ratio of areas. Then we're just going to take our side length, or perimeter area ratio, and square both of them. So it'd be 4 to 9, and that would be our area ratio. So let's look at example 2 here. It says you're installing the same carpet in a bedroom and den. The floors of the rooms are similar. That's a key thing. The floors are similar. So we know these two shapes are similar to each other. The carpet for the bedroom costs $225. So my bedroom, I'm going to put $225. Carpet is sold by the square foot. Okay, square foot. That tells me it's area. How much does it cost to carpet the den? So we're looking for how much does it cost for this one. Now, I've got these two pieces, 10 and 14, and I know those are similar, so I can write a perimeter ratio. Remember, that's the same thing as side length ratio. And I can write that as being 10 to 14. If we reduce that, it's 5 to 7. Okay, so that's our side length ratio, but this is based on the area. So we're going to have to use the area ratio. So to get from our side length ratio to our area ratio, I'm going to go to our area ratio. We're going to square it. So we're going to have 5 squared to 7 squared, or that'll give me 25 to 49. So now that I have my area ratio, I can now write and solve a proportion. So I'm going to use my area ratio that I've got, and I've got 25 to 49, and we're used to writing proportions as fractions, so we can do that still, equals, now this 225 is for my smaller room, so 225 is going to go on the top, and then x will go on the bottom. So if I cross multiply here to solve this problem, I'm going to have 25x equals 49 times 225. And then if I divide both sides by 25, that'll give me my x all alone. So x equals, if you put 49 times 225 and then divide it by 25, you should get 441. So that's $441 for this room, and the answer would be D. So notice we used our perimeter ratio that they really gave us. We found it from the picture. Change it to area ratio since we know our cost was based on the area of the room. And then from there, we were able to write a proportion. We're going to be doing that often, using the ratios to write proportions. Let's look at the other side of the page. All right, example 3 says cooking. A large rectangular baking pan is 15 inches long by 10 inches wide. We've got that written right here, 15 by 10. A smaller pan is similar to the large pan. Okay, so we know these two shapes are similar. The area of the smaller pan is 96 square inches. We've got that written here. Find the width of the smaller pan. Now here, area for this rectangle is going to be length times width, which they did right here. So they didn't tell us it in the words, but we know the area of this larger pan is going to be 150 inches squared. So looking at it, it looks like we can find the area ratio. The question says find the width of the smaller pan. So we're looking for this right here. Well, we know that we can write an area ratio. And that area ratio that we can write is going to be 96 to 150, because that's the area. And then if we reduce that, if you put 96 divided by 150 in your calculator, it actually reduces to 16 to 25. So from there, I know I want to find a side length, so I need to find my side length ratio. And to do that, last time we went the opposite direction, so this time instead of squaring it, we're going to square root both sides. So we want the square root of 16 and the square root of 25. So that will give us then, square root of 16 is 4, 2, the square root of 25 is 5. So there's my side length ratio. I can now write a proportion to find my missing piece. So I'm going to write 4 to 5 equals, now this corresponding side length is right here. These two are corresponding side lengths, and this is a smaller one, so it goes on top. So it's x over 10. So 4 over 5 equals x over 10. And then we'd solve that by cross multiplying. So we're going to cross multiply this. I have 5 times x equals 4 times 10. Now divide both sides by 5 to get x alone. So x equals 4 times 10 is 40, divided by 5 is 8. So my answer is 8, and my units here in inches. All right, let's look at this last one here. It says example 4, gazebo. The floor of a gazebo shown is a regular octagon. Okay, there's a key thing, regular octagon. So this isn't going to be a great picture. I'm going to sketch the picture the best I can though. So I got a regular octagon. So let's try this. Can't laugh at my picture because I'm trying. Okay, so it's not beautiful, but we know it's a regular octagon. So based on the fact that it's regular, we're going to make that all these are equal. 1, 2, 3. Let's make sure that 3, 4, 5, 6, 7, 8. Yep, I got all 8 sides on there. Okay, so I'm going to mark that those are all equal because it's a regular octagon. Right here. Each side of the floor is 8 feet, so I know all of these are 8. Okay. 8, this is 8, this is 8, over here is 8, even though we don't have space. And the area is about 390 square feet, so area equals 309, not 90, and that's feet squared. Okay, it says you build a small model of a gazebo in the shape of a regular octagon. Oh, now I need to draw a small one. Let me do my best to draw a small one. This is not beautiful. Well, we got 8 sides there. It's not a beautiful octagon, but I did my best. 1, 2, 3, 4, 5, 6, 7, 8. Not a regular one, that's for sure, but I did my best. So we built a small model in the shape of a regular octagon. It says the perimeter of the floor of the model, so the perimeter of the floor of the model is 24 inches. So I know for this one, my perimeter equals 24 inches. Here's my directions. Okay, the question that I'm trying to answer, I'm going to put the box around that one. Find the area of the floor of the model gazebo to the nearest tenth of a square inch. So this is what I'm looking for. Okay, so I need to be able to write a ratio. I've set up my whole problem. Now I know this perimeter, and because I know all these sides are 8, I can find the perimeter here. So if I do 8 times 8, I know that my perimeter here for this one equals 64 feet, since it's 8 times 8. So we can write a perimeter ratio. Now I know my units are the same, but it can still work out. So my perimeter ratio would be 24 inches to 64 feet. And if I reduce that, that would give me 3 inches for every 8 feet. And you can just do that by putting 24 divided by 64 in your calculator and then changing it to a fraction. It'll give you 3/8. So that's 3 inches to every 8 inches. Now that's my perimeter ratio. I want to find the area ratio though, because I need to find the area. So in order to find that, I'm going to square both sides. So I'll do 3 square inches, and I'm going to square that. Square my units too. And 8 squared, then it would be feet squared. So my area ratio is 9 inches squared for every 64 feet squared. So now that I've found my ratio, I can write and solve a proportion to find my area of my model. So I can say 9 to 64 equals the area that I don't know, so I'll just put an A, to 309. And if you cross multiply that, you'll get 64A equals 9 times 309. So I've got 64 times my area equals, that's 2,781. Divide both sides by 64, and you'll find that x equals 43.5. And we know that's our models, so it's in inches squared. So my area for my model is 43.5, and that would be inches squared. And that's my area. So notice I wrote my perimeter ratio because that's what I could find. Then I found my area ratio, and then I wrote a proportion. All right, this is the end of the lesson. Make sure if you have any questions, you ask me about them, and have a great day.